In the previous lesson, I discussed how to determine the number of significant figures when we're making a measurement. And so the question becomes, how do we deal with significant figures, or how do we deal with rounding when we're actually calculating values? So when I'm multiplying and dividing, when I'm adding and subtracting. And the answer is there are two different rules based on what type of calculation you're doing. So if I'm dealing with multiplication and division, okay, what I'll do, I'll actually complete the multiplication, and then I'm going to round my number, my final answer, to the number of significant figures of the measurement that has the fewest number of sig figs. So whichever number has the fewest number of significant figures, that number of significant figures is what I'm going to round my final answer to. And this applies to multiplication and to division. So to make this make sense, let's actually look at a couple of examples. So for example A, it gives me 4.56 times 1.4. So the first thing I'm going to do is I'm going to plug this into my calculator, and the answer I get is 6.384. Okay, that's my unrounded answer. Now, if I look at the two numbers I multiplied by, 4.56, there's a decimal present right after the 4, which means I'm going to be counting from left to right. Okay. 4 is my leftmost number, so I'm going to start counting on the 4. So I'm going to have 1, 2, 3 sig figs. Okay. 1.4, again, decimal is present, so I'm going to count from left to right. 1 is the leftmost number, so it's going to be 1, 2 sig figs, which means, based on the rule that I just read, this answer, 6.384, needs to be rounded to the fewest number of sig figs, which is going to be 2 significant figures, which tells me I'm going to want to keep the 6 and the 3, okay? And so when I'm deciding, do I round the 3 up or do I round it down, meaning leave it the same, I look at the next digit, it's an 8. The 8 will round the 3 up, so my final answer will be 6.4. And that's the correct number of significant figures because I only want 2. Let's look at another example. 298 divided by 8.315. So I plug that into my calculator, and the answer, unrounded answer I get, I'm obviously going to round a little bit in the interest of time, but 35.83885 is my unrounded calculator answer. Now, 298, there's not a decimal present, so I'm going to be counting from right to left. 8 is my first significant digit, so it's going to be 1, 2, 3, sig figs for 298. 8.315, there is a decimal present, so I'm going to count from left to right now. 8 is my leftmost number, so 1, 2, 3, 4 sig figs, which means, based on the rule, I want to have a total of 3 significant figures because that is the fewest number of sig figs. 298 only has 3, while 8.315 has 4. So, if I were to round, I want to keep the 3, the 5, and the 8. I need to see if the 8 needs to round up. It does not. It's going to round down. It's going to stay 8. So I'm going to have 35.8 for my correctly rounded value. So that's the rule for multiplication and division. There is a different rule for addition and subtraction. And the reason why these rules are different will make a lot more sense when we actually get into the chemistry of it, and you see why using sig figs when we're adding and subtracting simply does not make sense. So for adding and subtracting, instead of looking at the fewest number of significant figures like we did for multiplication and division, instead we're going to round your final answer to the fewest number of decimal places. Now, keep in mind, if you don't have a decimal or you don't have any numbers after a decimal, you have 0 decimal places. Just keep that in mind. So for example, if I gave you 8, that has 0 decimal places. As soon as I make that 8.0, that'll have 1 decimal place. If I made it 8.00, that'll have 2 decimal places, etc., etc. Okay. So let's look at this problem. 186.1203 plus 2.04. Okay, so I'm adding, so I know I'm going to have to use my rule with decimals. So my calculator answer is 188.1603. That's unrounded. Now I'm going to look at my two values, 186.1203. There are 1, 2, 3, 4 decimal places behind that one. For 2.04, there's 1, 2 decimal places, which means my final answer should only have 2 decimal places. which tells me I'm going to want 2 decimal places. The 0 does not round the 6 up, so my final answer is going to be 188.16, and that is my correctly rounded value based on the fewest number of decimal places. For example B, I'm subtracting, so again, fewest number of decimal places. 58.266 minus 1.1, an unrounded value is going to be 57.166. Okay, now I'm going to count decimal places. 58.266, you've got 1, 2, 3 decimal places there. For 1.1, you've got 1 decimal place, which means my final answer should only have 1 decimal place. All right, so what that tells me is I just want to keep this 1 because I want just 1 decimal place. However, that 6 is going to round the 1 up, so my answer is going to be 57.2. So just a quick review. When you're multiplying or dividing, you base your rounding off of the fewest number of significant figures. When you're adding and subtracting, it is based on the fewest number of decimal places, and that's it.